we go. Okay, this one's going to talk about the opposite parts in a triangle. So remember, we're talking about 6 parts here. We're talking about 3 sides and 3 angles. The first thing you need to be able to identify in a triangle is which side is opposite which angle. So in this triangle here, I've got in triangle DEF, I've got, I don't want blue. Angle E refers to this opening. How wide is this opening? Okay, but that's the angle. That's angle E. The side that's opposite of it is the side that doesn't make up a side of that angle. So you can see that this side is opposite of that angle. Okay, then we've got angle F, which refers to this amount of opening here. How much did that open? And the side opposite angle F is side DE. So angle F is opposite side DE. Angle E is opposite side DF. Whoops. All right, and that works the other way. You could say side DE is opposite angle F. And then lastly, what color can we go with here? I guess blue. Angle D, this opening is opposite this side here. So angle D is opposite side EF. And again, vice versa. You could say side EF is opposite angle D. I want to stress again, like if you look at angle D is made up of these 2 sides. It's the angle included of those 2 sides. So the side opposite is the side that doesn't include it. So that's how you identify sides opposite of angles. So what we're going to talk about is, it seems kind of intuitive if you think about the angle as the opening. Let's look at angle E for a second. I'm going to make it a small opening. Then which side of the triangle would be the smallest? Since angle E is the smallest angle, then the side opposite, DF, side DF is the smallest side. And that's true for the largest angle and the largest side. If I made E the largest angle in the triangle, so I'll make it obtuse. Here's my opening for angle E, a much bigger opening than before. Then in this picture, angle E is the largest angle. Then DF is the largest side. I'll separate those so you don't think they're combined. Right, so you can kind of see as I make E larger, the side opposite, so that's the side opposite. That's the side opposite gets larger. Let's investigate this. Here is some GeoGebra. So here is a triangle with all the measures on there. And if I move the A around, you can see the things that move the measures change, okay? So let's focus on angle C. That's the angle there on the right. That is 7 degrees right now. Let's look at the lengths of the sides. CB is 8.47 units long. AC is 8.52. And then side BA, it's hard to see there, but it's, now I'll make it that so we can see it. It's 1.43. So the smallest side is 1.43, which is BA, which is opposite angle C, which is also the smallest angle. 9.62 is the smallest angle. What's the largest angle? It looks like angle B is, because it's 86.7 degrees. So the side opposite angle B, which is AC, should be the largest side. And not by much, because B is just slightly bigger than A. So that's what happens. You can see that AC is bigger than CB, but not by much. The next thing I'll look at is, what do you think happens if they're the same? Can I get these to be the same length? I'm looking at those sides. 8.45. There they are. What happens if the side lengths are the same? Look at side CB and side AC. The angles should be the same. Ooh, they're not. That's probably because of rounding error. This program probably rounds. Let me see if I can get the angles the same. That's going to be much more of a challenge. Close. Oh, I had it close there. Can't do it. Anyway, when if you make two angles the same, right? If I said these angles are the same measure, oh, my pen just died. Then you know two of the sides in the triangle are the same measure. So, I don't know. That just kind of naturally is what you would think about when we talk about the size of the angle. If those two openings are the same, then their sides opposite have to be the same length. So it's kind of cool. You can, if you know that two sides are congruent in a triangle, then you can know two angles are congruent in a triangle. Thank you. Goodbye.